Hi, I'm Adam White, and along with my partners,
Sara Redlick.
And I'm Pilczuk.
Working along with Howard Kaplan in the USF 3D printing office, we have been working in conjunction with the James A. Haley Veterans Hospital to assist a veteran who has lost all of his fingers and his legs to be able to golf again. So what we have been tasked with is to develop a 3D printed device to enable him to golf as he has been unable to do for the past few years. Here is our latest design. As you can tell, the Velcro straps are a little long and will have to be corrected for the final product. However, the intent with the design is the same. We have a finger that is used to hold the club as such, and then a strap to hold the patient's hand within the design to maintain connection with the club. So the patient would enter the hand as this, which would hold it in place. It is pretty firm. And then the club would be held like this. And as seen, it is very good at holding in place, and so then it would use as expected.
The first step we took in order to begin work on the prosthetic was to meet with the patient at the VA hospital in order to see what it is that we needed to do to get him golfing again. We took 3D scans of the patient's hand so we could have some accurate dimensions and a 3D model to be able to build the prosthetic around. Here is how the patient grips the golf club without the use of our prosthetic. Once worn, the prosthetic will improve the patient's grip tremendously. The first step of making the prosthetic hand was to draw a sketch of it to help us conceptualize how it should look and work. This is one of our earliest sketches. The next step to making the prosthetic was to make a physical model of our sketch out of cardboard. This is a picture of our cardboard model. It's not much, but we wanted to demonstrate how the prosthetic could possibly grip a golf club. Started to get further into the process of making the prosthetic, we needed to get more accurate dimensions of his hands and how his hands grip the club, and also make note on the angle of his wrist when holding the club. When we went back to the VA to meet with the patient, we took a mold of the patient's hands holding a club using this modeling material called blue pasta. Blue pasta is comprised of two separate materials that, once mixed together, allow you to mold a clay-like structure around an object and within a few minutes the blue pasta hardens. Once hard, the blue pasta is cut off the patient's hands, and then a cement-like mixture is poured into the blue pasta mold so that an accurate model of the patient holding a club can be formed and dried for use in helping us to get the right fit of the prosthetic for the patient's hands.
Here are some initial 3D printed designs that were implemented in the beginning of our design stage. To the left is a solid 3D printed hand from the original scans of the VA patient. This helped allow us to design around his specific dimensions of his hand. The hook design was one of the first designs that came to mind. This design eliminated having several 3D printed pieces and less time to produce. However, the patient wanted to have the design look more realistic, like an actual hand. So then the one finger design was created and had a boa system to tighten the finger easily back toward the palm to grip the golf club tightly. But this design wasn't feasible for the patient to put on, so we developed our final design to fit his hand like a glove. However, some minor modifications will need to be done in our final design. Hopefully this collab with the VA will help lead to many other opportunities along with patients who need 3D printed prosthetics to help provide assistance with daily activities. Here is Mr. Myers successfully swinging our latest version of the 3D prosthetic glove design. We would like to thank Howard Kaplan and Dr. Michael Cartel in allowing us to work with the VA directly with Mr. Myers. And we would like to thank Dr. Anna Pyatt for running the Modern Biomedical Technologies course.